Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we're going to see the second example of the simplex method. This is in a special case. So, special case. So, if the solution is unbounded solution. So then how to figure out whether the solution is unbound or not. So this is also, this is a minimization problem. So example 3.5, simple 3.5, minimize f of x or simply f. Now we said that in this particular book, capital F is used for maximization and smaller f is used for minimization. So basically minimization of the function with minus 3x1 minus 2x2. And the subject to the condition or constraint x1 minus x2 is smaller or equal to 1. 3x1 minus 2x2 smaller or equal to 6. And also xi is given to be greater or equal to 0. I is 1 and 2 because we have two variables, x1 and x2. So first thing is writing the standard equation. So we have said in the previous lecture that in this we have to make in the objective function x1 and x2 as 0. So basically we have minus 3x1 minus 2x2 is there. Then we have to bring minus f to be on the same side. So minus f equal to 0. And if you want, you can take f star as well. If the negative sign is confusing you, but you can always take negative sign, no problem with there. So 3x1 minus 2x2 equal to 0. So after doing that, next thing is to go for the standard form. Okay. So what is our standard form? Basically minus f. As I said, your choice. You can use f star or minus f. So minus f minus 3x1 minus 2x2. We have two constraints, so two slack variables you have to add, plus 0s1 plus 0s2 equal to 0. So this is objective function. Then we have x1 minus x2 plus s1 plus 0s2 will be equal to 1. And 3x1 minus 2x2 plus 0s1 plus s2 equal to 6. Okay, so once we have the standard form, then our next target is to figure out, next objective is to form the table. So initial iteration. So initial iteration. So basic variable, then we have all variables. In this particular case, we have x1, x2, s1, s2. Then we have right-hand side values and the ratio. Ratio is basically right-hand side values divided by the key column. Okay, so just extend the table. So our basic variables are basically here. We always said, we already said in the last class that basic variables will be along with our objective function, objective variable, that is f, and the slack variable. So S1 and S2. With that, we have our minus f or f star. Which one you prefer? There's no problem with that. Okay, so now let's fill up the table. So -3, -3, -2, 0, 0. Here we know that it will be 0, 1, 0, and 0, 1. So rest is basically 1 minus 2 and 3 minus 2. Sorry, 1 minus 1 and 3 minus 2. Okay, so next thing is to figure out the most negative one for choosing the key column. So this is most negative. So this is most negative. So this is our key column. Then next is finding the ratio. Oh, we forgot to write the right-hand side value. So basically 0 and 1 and 6. So 1 by 1 is your ratio is 1, and 6 by 2, 3, the ratio is 2. So this is the smallest one. So we pick this one as our key row. Okay, so key element is basically this one. So from this one, we know that our X1 enters and S1 leaves for the next table. Okay, so iteration, this is our initial iteration, then our iteration 2. So, and iteration 2, you can also write it here, iteration 2 or iteration 1 based on whether you're mentioning initial or iteration 1, that one. Okay, so it's up to you. So now again, our variables will be, we're just continuing the same table. So you're writing just a slack variable will be replaced by X1, then the second one S2, and your F. So actually it's better to write the appropriate notation, that is minus F, okay? So let's see what happens, whether we have to go for another iteration or not. So now here, the key row will be as it is because the key element is 1. So 1, minus 1, 1, 0, 1. No change. Next, for what will be, if this is your R1, R2, and R3. So R1 prime is same as R1. R2 prime will be R1. R2 prime will be R1 plus 3, basically R1 minus 3 R1. So R2 minus 3 R1. So basically 3 minus 3 will be 0. So we know that we have to make other two 0. So to make that 0, this is the formula that we are using. And if you apply that thing, that means -2, then -3. So basically it will give us -2 and -3. We'll subtract -2 minus -3. So it will give us 1. Then 0 minus 3. So -3. Then you'll have 1 minus 0, it will be 1. Then 6 minus 3 will be basically 3. And here, actually, if we just write R3 prime equal to R3 plus 3R1. 3R1. So definitely this is 0. Then R3 is basically -2. Oh, it's better to write the prime here. Otherwise, even though they're same, just to avoid confusion. So basically, -3, -2, -2 plus basically -3, so -5. And then you have 0, but plus 3 is 3. Then 1 plus 0 is 1. Okay, so 0 plus, okay, 0 plus 0 is 0. And 0 plus 3 is basically 3. Okay, now as you can see, most negative is this one, most negative of the second iteration. Yet not all of them are actually non-negative, so you cannot stop. So you can see that this is most negative here, and that gives us, this is our key column. And which one is our key row? For that, we have to find out the ratio. So right-hand side value, 1 minus -1. So it's basically -1. So we cannot take this one. The other one is 3 by 1, that is 3. So you have to take this one as a key row. So our key element is becoming 1. And now which one is entering? So we can conclude that X2 is entering. This is actually X2. And S2 is leaving. So X2 enters and S2 leaves. So very quickly, try to extend this table a bit. We can write the iteration here if you want. Iteration 2. Then we have those values. So next value, already we have X1 previously, now X2 is leaving, X2 is entering. Then we have our -f is the function. So let's see whether we can go up to the stopping condition or not. So now, since the key limit is 1, we don't have to change it. So just keep it as it is, -3, 1, 3. Okay, so next, R1 double prime will be, so your R2 double prime is basically nothing but R2 prime. So now here what you have to do is, this is 1 and this is -1. So if you just add those two, then it will be good. So R1 prime plus R2 double prime, which is same. So it doesn't make much difference. So we know that we have to make other terms 0. So this is what we have to do. And to do that is the formula that we have to apply. And now you can see that if you add those two, it will give you 1, 0, then it is -2, then 1, and 4. Similarly, now for the other one, as you can see, this is 1 and this is -5. So your R3 double prime has to be R3 prime plus 5R1. So now 5R1, 5R2. So now if you apply that 5R2, R3 already is 0. So 0 plus 0, 5 into 0 is 0. This is already 0. Then 3 minus 3 minus 3 into 5, that is 15. So basically minus 12. And this will be minus plus 5. So basically 5 and 3 plus 15, that is 18. Okay, so as you can see, we haven't yet arrived to the condition. That means all of them are not non-zero, rather all of them are non-negative. So this one is negative, so you cannot stop. Now, this is your definitely the key row, key column. So this is our key column. And let's find the ratio. So the ratio is -2, we cannot take. And this is -1, we cannot take. So neither of them can be taken. Neither can be taken. So when this situation occurs, this is a condition for unbound solution. So if we cannot take any one of them, so what does it mean? That even though we didn't approach to the stopping condition, we can keep taking the values, replacing those values, but the values of x1 and x2 with the further change will go to the minimum more and more negative values. Okay, so this is unbound scenario. Okay, so if this is arrived, then we have to conclude to the solution situation. We have to conclude that this particular problem doesn't have a specific minima, so it will keep going to the negative values with more and more iterations. So there is no point of continuing on that one. So we just conclude that thing with saying that the problem is of having unbound solutions. So this was your example 2 of the simplex one in a very short video. So we'll try to see the last case, last spatial case in the next video, inshallah. Assalamu alaikum wa rahmatullah.